Seems like the weekend is where all the best stuff happens. This is something that's occupied me for the last 3 weeks, and I am just relieved and happy that it works because to us this has been one of the biggest open problems for us to tackle. Let me show you something really fun, right? I've got a bunch of data in here that's really horrible data in a lot of ways. Some of it I created, some of it's from other platforms where I just exported it out. Um, but it's amazing that now I can just do this. I can throw in a flights JSON file that looks like this. It's nested. Nobody knows how the dates are encoded. Nobody knows how the hours work. Nobody knows what some of these fields even mean. But it's created this beautiful, flat, relational structure, transformed the data, figured out the foreign key relationships, connected it all together. So I can just ask, what's the fastest non-red eye, which is, almost culturally a connected question in terms of what a red eye flight even is, but it figures it out, right? And this is something that I spent a week writing the ETL pipeline for that very first demo of Visual Search. If you look through the repo, you'll still find my work there. And this is something that we at Graywing have spent about 40% of our dev time just building pipelines for transforming this data. Now I get an answer, and I can just ask, what's the general distribution of fares? Because the problem with modern structured search with AI is we really see the power of it because it can take human requirements and convert them to SQL, convert them to ways where we can search the data. And that is perfect. That's exactly what I was looking for. But the problem is most data looks like this, right? Most data is either nested JSON or Excel because we don't always own our own data. They sit with providers and you live with the export formats they give you. Most of our data is not sitting inside Postgres, well structured and well typed out. Even at my own company, our data is not sitting in a clean Postgres database. It's sitting in a Postgres database because I'm a little strong that way, but it's sitting in places where that's not easily always accessible. That's what you have to interface with, and that's software engineering work that we've always had to do. But almost all of them export to some form of nested JSON, NoSQL data because it's very easy to generate. You just nest everything you want to, or Excel because it's still the kind of lingua franca of data. And so here's a bunch of meeting data that I exported, right? And I can just pull that in. There we go. And I can just ask, um, and it'll figure it out and give me an answer, right? And this is a case where this is not a big DDL, but even just figuring out what each one of those things are and dealing with time is often just a massive, massive pain. And someone remind me to congratulate Nick for creating 1,000 total events. I have no idea how he manages it. What it also means is I can take something like this, you know, which is really, really large data, not just number of rows, but also just in terms of how many columns there are. And I know because I built the ETL pipeline for this manually when we were deploying it to a customer. No question can be answered in this data without multiple joins across all of it. So now it's amazing to me that I can just ask, something more complicated like how did the charterers, and I need a full report. And it's then able to take all of that and put all of that information and connect all of it together, figure out what the actual values in the database are. Because even though this looks like a thick prompt, it isn't really because the complexity gets reduced by some of the explanations. It's almost like you're surfing the latent space to make it easier for the model to understand and sort of constrain the output. Okay, we had a bug in the query. That usually happens too. But oftentimes with one or two lines of reflection, that easily gets fixed, right? And it's the same as if it's a query where you can't expect a human to get that query right the first time, it's often unreasonable to ask a model to get it right the first time. But with the right reflection, you can get it. And the really, really amazing thing here is that this all happens without arbitrary code generation, without model written code being executed. I'll tell you why that's important in a second. But this is interesting because you can now see all of this has been well typed and not just in syntax, but also properly into currency and the type of currency and the dates when the dates are present. And this is data that's very easy to chart. This is data that's very easy for any automated system to consume. So those two pieces together, you know, make something really, really useful. And the reason that arbitrary code, I'll give you one more data set while I tell you about that. Let's take, the commit data. There we go. And I can just go, what's you know, this one I've always wanted to do, but I never wanted to write the code for it, right? I never wanted to really do this because the thing is, it's not actually part of the data set. You would kind of have to figure out and look through the file names and then write that mapping to eventually get the query out. But it feels like it's actually uh, probably figured it out. That's the that's the query that I wanted. Although the way that the queries are detected, I don't think it's going to work. I'm just going to try that again. No, because I can. Let's see what happens. So what actually happens is without arbitrary code, you can provide stronger security guarantees. And that's always been a rule for us, is to provide that separation, that von Neumann level separation between code and data. And it's also in some cases just a general red herring, right? Because same as here, finding code that executes correctly and without errors is not always a good proxy for the correctness of that code. I know because I write code that executes without errors and it still isn't correct, right? And no amount of loops can oftentimes get it there because what you really want is constrained output. And I'll show you one more problem that arbitrary code generation really has when we go into the intermediate outputs and how controllable that is. There we go. That's one example of the number of lines added, but it didn't really break it down by programming language, which is surprising. Let's go into this. This has been my white whale. A friend passed it to me. This is chain data for a complicated stablecoin protocol from Ethereum. And so there's all sorts of nested data in there from across different chains. The data looks like there is a type spec, but it, betrays and denies its own type spec multiple times. I know because I tried to manually write an ETL pipeline, and so did he. And we both patently failed. So it's going to be interesting if this works. There we go. And I can ask a question like, and just to look at this DDL, it's just massive, right? This thing is huge. It's 5,000 lines in the structured DDL form. That's code that a human would have had to write, verify, and check. But it looks like now, in about a millionth of that time, I've gotten to my answer. Right, and I'm not saying this is entirely right, but the thing here is once you've got that pipeline working and working deterministically, you can then start to improve it. You can then start to fix it. At this point, I know there are 1,000 bugs in my code. I just need to go and fix it. So before we close, let's just look at the intermediates here, right? So if you just look at the bank data and I just look at the structure, this is the structure of that data. This is how it's encoded. And Visual Search does it today. You can check out the type specs directly in the repo. What it is it's trying to pull out as much information as possible, but in as structured a format as possible. So we call it a structured DDL because it essentially is that database definition, but made bigger, where it encodes things like examples, how to pull examples, what kind of range it is, if it's a date, what type of date, and how to process that date into a real date, and so on and so forth. And there's other controls that can be changed around whether that gets exposed to the LLM or not in terms of generation. And all of that gives us just a huge control surface. And structured DDLs have always been part of wishful search. But there was a kernel of an idea at the beginning of wishful search, which was the auto analyze function, which helped you build that ETL pipeline, right? It got you 50% of the way there. And it made so many mistakes, which is why it outputted to a markdown file because I really didn't want people executing that code without ever looking at it. But a lot of people who've used wishful search have come back and said it makes it so much easier that some of that grunt work is done for me. That made me go, what if there was enough information in the data itself for you to infer things about that data enough to do that ETL yourself? And so that is where we eventually get to the mapping. This mapping.json is a mapping between the eventually generated tables and the original data. And then there's another mapping JSON which connects different headers and different things based on meaning. Now, the advantage of having all of these intermediate steps is that now it becomes inspectable. Now it becomes directable. If you build it, if you run these things through and I see, oh, there's a problem there, there's something only a human can know, right? Maybe you just misnamed a column. That's a very, very easy fix. This is a very easy UI to build and very easy UI to represent and sort of edit. And now you're directing that. And once you've got a good pipeline, it's now just represented in data, not in prompts where model changes can affect it, not in prompts of, generate the code to fix this, but don't do this, but do this, but don't do this, but do this. And then you're just building, deck of cards that eventually collapses once it gets big enough. It's a lot easier to encapsulate business logic, personal logic in here, edit it, and know that it is right. Right? There's also a type spec being created, but that is, largely for my consumption, and also to constrain the development here. So some of the stuff that you might have seen on my Twitter, which is just matrix looking stuff, is just this generation process runs about 15 to 20 prompts that don't run for very long. They're not very expensive, but they all run at the same time. So I usually try to print them all to the terminal because that's kind of fun to look at the jumbled output. That's just me being weird. But if we look at NV here, you can see the structured JSON that got generated. It's not a small one. This is also pretty big. But you see all the places where it's identified different things like total port base and how that's represented, distance traveled. Half the descriptions in here I didn't even know. I had to go to Nick to get the answers there. So hopefully that's told you a little bit about how exciting this is for us, right? I think it's exciting for a lot more people because I think most of our data sits in places where current generation AI search can't get to it. And so this hopefully is that connecting link. But if there's nothing else, I think we have effectively removed this massive chunk of work from our plates moving forward. And this is something we're hoping to release, something we're hoping open source when possible. My next thing is immediately delete all of this code because it works, but it's the worst thing I've ever written. The point of it was just to see that it could work. So we're going to rewrite it. We're going to fix everything up. But I just want to share that, I'm just very happy about it. And I hope everyone has a good weekend.